All right, in this lesson we're going to learn how to use the law of sines and the law of cosines to find missing sides of triangles. Okay, one thing to keep in mind here is you do not have to have a right triangle to use the law of sines or the law of cosines. So the law of sines sets up a ratio with an angle and its respective side. As a reminder, the sides are opposite the angles and typically labeled with lowercase letters. Keep in mind, because these are ratios, we can also take the reciprocal, side A over sine of A will equal the length of side B over sine of angle B, and the length of side C over the sine of angle C. So you can either put the angle on top or the sides on top, but keep it consistent. Okay? One thing you want to look for in order to use law of sines is that you have what I am referring to as a full ratio. You have an angle and its associated side. This is what I'm referring to as a full ratio. You have a full ratio and you have another angle, then you can go ahead and use the law of sines. Okay? So the first thing I'm going to do is solve for side A. Notice that our full ratio involves angle B and side B. So I'm going to take the sine of 72 over 12 and set that equal to the sine of angle A, which is 45, over lowercase a. In this case, you're going to cross multiply, so you have A sine of 72 equals 12 sine of 45, which means A is going to equal 12 times the sine of 45 divided by the sine of 72, which gives you a side of 8.9, and I'm rounding that to the nearest tenth. Now, if we want to find the length of side C, notice we do not have the angle measure of angle C, so we need to find that first, and we know that the sum of all the angles in a triangle is 180. So we're going to take 180 and subtract 45 plus 72, and that gives us 63 degrees for angle C. Now, when you are doing law of sines, always use the full ratio for a couple of reasons. Notice this is 8.9, which means I've rounded it. You don't want to reintroduce some rounding, and I may have made a mistake. So always go back to the full ratio. So in this case, sine of 72 over 12 is going to equal the sine of 63 divided by C. We're going to cross multiply. C times the sine of 72 equals 12 times the sine of 63. So that means C is 12 times the sine of 63 divided by the sine of 72, rounding to the nearest tenth. I'm going to get 11.2. And you can do a quick check. The largest angle is 72, the longest side is 12. The next largest angle is 63, it is 11.2, the side is 11.2. The smallest angle is 45, and A is the shortest side. So we've got those all in order. All right, moving down to this example here. Again, look for your full ratios. We have angle D and side D. So we can set up our proportions. Sine of 73 over 8 has to equal sine of 41 over lowercase f. Cross multiply. F times the sine of 73 equals 8 times the sine of 41. So f is equal to, let me get that up a little bit higher, 8 times the sine of 41 divided by the sine of 73. I'm going to take that out to the nearest 10. We have 5.5. To find the length of side E, we first have to find the measurement of angle E, which will be equal to 180 minus 73 plus 41, which gives us 66 degrees. So E should be somewhere, the length of E should be somewhere between 8 and 5.5. Again, we go back to our full ratio. Sine of 73 over 8 is now going to be set equal to sine of 66 over side E. We cross multiply. And that means E is equal to 8 times the sine of 66 divided by the sine of 73, which gives us 7.6. And it does fall between 8 and 5.5. Now, the other law we can use is the law of cosines. And it's given to you as side A squared is equal to side B squared plus side C squared minus 2 times the lengths of B and C times the cosine of A. And it follows a pattern. So if I want to find B, B squared equals A squared plus C squared minus 2AC cosine B. And C squared equals A squared plus B squared minus 2AB cosine C. So you have those written out depending on what side you're looking for. So in this problem here, we want to find the length of side A. So I'm just going to take the square root of this entire thing. That means A is going to equal the square root of A squared, sorry, not A squared, B squared plus C squared minus 2BC times the cosine of A. Plug in those values. B is 10 squared, C is 9 squared, minus 2 times 10 times 9 times cosine 41. And again, check your calculator. Make sure that it is in degrees. We get 6.71. I'm going to go ahead and round it to the nearest tenth. And we get 6.7, which makes sense because 41 is smaller. It's probably the smaller angle, and so this has to be 6.7. All right. So moving down here, notice that this side is opposite of angle C. So we're going to take C equals the square root of, this is A, and this is B. A squared plus B squared minus 2 times A times B times the cosine of C, which is 65 degrees. You can plug this all into your calculator in one fell swoop, and you should get 11.26. If I'm rounding to the nearest tenth, that gives me 11.3. Okay? Now, for this last example, you actually have two options. You can solve it by law of cosines, because this is a lesson on law of cosines, but also you could use law of sines because we have full ratios. But before we do that, we need to make some editorial changes. we need to change this side length to 5 and this side length to 3.9. So, regardless of whether we're going to use law of cosines or law of sines, we need to find the measure of angle A. So angle A is going to be 180 minus 43 plus 61, which gives us 76 degrees. So as I look at this triangle, based on the angles, x must be greater than 5. Okay? So we're going to start with law of cosines. Law of cosines tells me that A should equal b squared plus c squared minus 2bc cosine A, which is 76. Okay? And if you plug that in your calculator, you get 5.54, which when we round it to the nearest tenth is 5.5, which is longer than side C, which is 5. Okay, that's law of cosines. All right, now I'm going to solve it with the law of sines. And notice we have two full ratios, okay? And I'm going to go ahead and use this ratio here because I want to avoid decimals since I have that option. So we have sine of 61 over 5 must equal sine of 76 over A. We cross multiply. We divide by sine of 61. And we get 5.54, which rounds to 5.5. So again, you had two options in this problem here because you had a full ratio. You actually had two full ratios.